Greetings. So this is going to be a quick tutorial on the Unit 2, Day 5 implicit differentiation notes. Okay, so here are your notes. I was just going to walk through a couple examples in case you needed just to revisit them. Okay, so remember the big deal with implicit differentiation is that you have more than one variable. And so what we want to do is basically take the derivative with respect to another variable, and then we are going to be able to solve. Okay? So in this, I'm going to do part B here. So when you take the derivative of something that is just an x, so if we're trying to find the derivative of y with respect to x, that means if whatever this variable is in the denominator there, that x, that means if you are going to take the derivative of something and it's not an x, then you need to tack on and multiply by this dy dx to kind of cover yourself there. So let me scooch this up here. All right, so here when we take the derivative, well, that's just an x, so I get a 2x, and that part's fine. But then when you take the derivative of the next part, you're going to have to use the product rule inside of there. So it's minus, okay? And when we do this, it's going to be first, well, the first part is the 2x times the derivative of the second. Well, the second thing is a y. The derivative of y is just 1, but since I took the derivative of something that's not an x, I need to tack on a dy dx. Okay, so that's first times derivative of the second. Now it's plus the second, well, the second is just y, times the derivative of the first thing. So the derivative of that first thing is just a 2. That's times 2. Okay, and now I'm taking the derivative of the next term, so plus 2y, and again, I just took the derivative of something that's not an x, so I tack on a dy dx. And that equals, the derivative of 4 is just 0. Okay, so now you can take a minute and distribute this negative. Okay, so once we distribute that negative, you get a negative 2x dy dx. And then that would be a 2y, so now it's going to be a negative 2y plus 2y dy dx equals 0. So my goal here, it says find dy dx. So my goal here is to get this dy dx by itself. So what I'm going to do is I'm going to move this term and this term to the other side, and then I'm going to factor out a dy from the terms that are left. So you could do that in 1 or 2 steps. I'll do it, well, first I'll take out, let's see. So we'll have negative 2x dy dx, and then I still am going to have this plus 2y dy dx. And then if I move this and that to the other side, it'll be negative 2x, and it'll be a positive 2y. Okay? And now I'm just going to factor out the dy dx. And you could factor out the 2 if you want, but I'm just going to factor out the dy dx. So then I'm left with negative 2x plus 2y over here equals negative 2x plus 2y on that side. Solve for dy dx by dividing both sides by this, but what you'll notice there is something kind of nice happens that won't necessarily always happen, but you get negative 2x plus 2y divided by negative 2x plus 2y. Well, anything divided by itself is just 1. So my answer to that problem is just a 1. You'll notice that your answer isn't always such a nice numeric. Over here, you still had variables in your answer, so that was just kind of a nice little coincidence there. Okay, so we'll kind of do the same thing for this next part on part B here. So right away, we're trying to take the derivative here, and it's a 2y, but I took the derivative of something that's not an x, so I need to tack on that multiplied by the derivative of y with respect to x. Okay, so then we have minus, and then I'm going to use the product rule. I like to kind of do my product rule inside and then distribute my negative. There's nothing that says you can't just treat it as a negative 5x there, but I like to say first times the derivative of the second. Again, the derivative of y is just 1, but I need to tack on that dy dx. Okay, first times the derivative of the second, plus the second is y, times the derivative of the first thing is just 5. So it'll be y times 5, which we know is just 5y. Close that up. And then plus the derivative of this next term is a 14x and equals 0. Okay, so you can distribute the negative And that becomes negative 5y plus 14x equals 0. And all right, so here my dy dx's are here. I'm going to move these two to the right-hand side of the equal sign, and I'm going to factor out this dy dx all in one step. So I'm taking out the dy dx from these two terms, so I get a 2y minus 5x equals, and then I'm going to move these two to the other side, so it'll be a positive 5y and a negative 14x. And again, my goal is to get dy dx by itself. So dy dx equals, so my final answer is 5y minus 14x over 2y minus 5x. And no, you may not cancel those 5s. That is breaking some big math rules, so don't try to break those. Okay? All right. We'll take a look at the next page in just a sec. Okay, I'm going to go over this you try it too right here. It says find the equation of the tangent line to the curve at the point 1, 1. Okay, so again, we're seeing this vocabulary in that sentence there. Find the equation of the tangent line. Well, your goal when you're trying to find the equation of the tangent line is to take a derivative. Then you need to plug in to get the slope. And then you're supposed to use that point slope formula. So that's kind of been our method. The difference here is now when I go to take the derivative of this, I have to use implicit. So my derivative here is going to be 2x plus, then here you have to use the product rule. So it's first times derivative of the second. So I have to use the implicit there, plus the second times the derivative of the first. And then here, I have the derivative here is just 2y. And again, whenever you're taking the derivative of something that's not an x, then you need to tack on that dy dx equals 0 because the derivative of 3 is 0. So I went through. I have the dy dx's. I factored out the dy dx from this term and this term, leaving me with that. And then I moved this and this to the other side. So I get here, solve for dy dx. I just divide both sides and I get to there. So that's finding the derivative. And now I need to take that derivative and evaluate it. So how do we write that? We're going to say that we're going to take the derivative and we evaluate it at the point 1, 1, because that's what they gave us. So again, kind of following that method, I took a derivative, check. Now I need to plug in to get the slope. So let's see. If I evaluate the derivative at 1, 1, all I'm doing is taking x equals 1, y equals 1 and plugging it in. So that leaves me with negative 2 times 1 minus 1 over, and then if I plug in a 1 there, okay. So just clean that up. Let's see, negative 2 minus 1 is a negative 3, and my denominator is going to be a 3. Oops, sorry, it'll be a 3. That's a positive, so it was x plus 2 times 1, so that's a 3. And I get a negative 1 for my slope. Guys, that negative 1 is the slope of the tangent line at x equals 1. Okay? So, when I have that, now I plug into my point slope formula. Y minus y1 equals m, parentheses x minus x1. So, I've got my points. There's my x1 and my y1. I've got my slope. Okay? So now you're just dropping them in. So it's y minus y1 equals m, parentheses x minus x1. So there is what I call your safe stop. That would get you full credit on the AP exam. But if it is a multiple choice question, you're going to want to distribute. So that would give me a negative x, and that'd be a plus 1, and then another plus 1, so that would be a plus 2 as my final answer on that. Okay? Okay, in example 3 now, it says, at what points does the circle given by that have a horizontal tangent line? Okay, horizontal tangent line. First I want to know, what does that mean? A horizontal tangent line. Well, a horizontal tangent line means you're going to take a derivative and you set it equal to 0 because horizontal lines have a slope of 0. What is slope in calculus? That means the derivative. So I need to take the derivative, set it equal to 0. So derivative equal to 0. So now I go to take a derivative. Okay, I took the derivative. Oh, I'm going to use implicit here. So you use implicit differentiation. Again, what does that mean? When you take the derivative of x, it's just normal. But when you take the derivative of something that's not an x, then you take the derivative and then you have to multiply by it dy dx. Now I solve for dy dx. That is the derivative. And I just simplified here. So I took the derivative and now I need to set that derivative equal to 0. I even like to write that down, dy dx equal to 0, because sometimes on the AP exam, just stating that would actually get you a point, even if you messed up solving it. So now I have negative x over y equals 0. Well, when is that going to happen? Basically, if you multiply both sides or whatever, you would end up with negative x equals 0, right? Think about it like this. Cross multiply, you get negative x equals 0, and divide by negative 1. That's going to happen when x equals 0. And now I need to figure out what's going on at x equals 0. So let's see. At x equals 0, okay, that means I have to plug in x equals 0 into the original equation, okay? So I plug that into the original, so I get 0 squared plus y squared equals 4. Well, that just means that y squared equals 4, and that must mean that y equals plus or minus 2. So that's y equals plus or minus 2, okay? Once you have that y equals plus or minus 2, that gives you the points. So horizontal tangent line, okay, at what points? So the horizontal tangent line is at x equals 0, so you have 0, 2, and at 0, negative 2. So we have that. And then down here it says a vertical tangent line. Well, when does a vertical tangent line occur? A vertical tangent line occurs when the derivative equals 0. Or I'm sorry, I misspoke. A vertical tangent line occurs when the derivative is undefined. Guys, I misspoke there. The vertical tangent line occurs when the derivative is undefined. Well, when is this derivative going to be undefined? If you go back here, it has a denominator. So vertical tangent line when dy dx is undefined. When do we have things that are undefined? When your denominator equals 0. So that means that when y equals 0, that would be a big problem because that would be undefined. And so, well, let's see. If y was 0, you have to kind of go back and plug in there, right? You can even, if you need to write that line of work, at y equals 0, x would be plus and minus 2. Because if you plugged in y equals 0, you're just going to get x squared equals 4. Square root of that is just plus and minus 2. So then that would be at negative 2, 0, and 2, 0. You would have a vertical tangent line. So you've got that one. And real quick, we'll just kind of talk through this you try it 3. So when we talk about this you try it 3, again, you're going to use implicit differentiation here. So if this equals 0, what is the value of the derivative when x equals 1? So it's not asking me, like it did up here for the equation of the tangent line. It's basically saying you don't have to do as much work this time. So when we take the derivative here, be careful, it's going to be implicit, and you're going to have to use the product rule there. So I'm going to fill that in. So after you go ahead and use your product rule there and the implicit differentiation, okay, you get back to, when you solve for the derivative, you get something divided by itself again, so you get that that equals 1. And make sure that you're answering the question. It just says, what is the value of the derivative when x equals 1? Well, it doesn't matter what the value of x is. The value of this derivative is always going to be 1. So I answered the question there, and that's done. So just remember, if you have x's and y's in the same problems, you want to use implicit differentiation to solve. So there's your quick 15-minute tutorial over implicit differentiation. Have a great day.